Good day, students. On this clip, we're going to be going over two examples and how to factor using difference of squares formula and also how to factor perfect square trinomials, right? So let's go ahead and write down the instructions for the notes for today. So factor the following expressions. Factor the following expressions completely. All right. So let's take a look at number one. Number one, we're going to factor 3x to the third minus 27x. Okay. So whenever you're factoring, it's a good strategy to always break it down to examine if there are any greatest common factors that can be factored from the original problem before we use any factorization method. All right. So let's break this down and see if there are any common factors. All right. So we have 3 times x times x times x. That's the decomposition of the first piece minus 27 is a little bit hard, so let's break it down on the side. Take out 3 times 9, and then take out another prime factor of 9, which is 3, and you're left with 3. So 27 is basically 3 3s, all right? So 27x can be decomposed into 3 times 3 times 3 times x, all right? Now, is anything common on both sides of this factors expression? Yes, we have 3 and a 3, and then we also have an x and an x that are common on both sides, okay? So what does that mean? We're going to factor them out. So we're going to factor out 3x, all right? So that is as though we divided this expression by 3x when we factored out 3x. So this 3 and this 3 factor out into 3, and this x factor into this x. So what are we left with? X times x, which is x squared, minus 3 times 3, which is 9, okay? Now we have a square, a difference symbol, and a square. So we're going to use the difference of squares formula to factor this. So what we do is we read the first and the last, and then we're going to add and subtract the square roots. Okay? So this greatest common factor that we pulled out, we just bring it down. So the square root of x squared is x plus 3. That's the sum of the square roots times the difference of the square roots, which is x minus 3. All right? So there goes the factored form of the original expression. So let's go ahead and box our final answer. All right, let's go ahead and try another example. In this case, we're going to have a quadratic trinomial. Number 2, we're going to be factoring 18k squared minus 24kt plus 8t squared. Okay, so are there any common factors that can be taken out of all three terms? Well, I'm not sure. So let's go ahead and break each term down and then decompose this whole thing into the prime factors and then see what's common, all right? So let's start with 18. Since 18 is even, I can take out a prime number 2 because it's even, and then I'm left with 9, and then 3 goes into 9 3 times. So 18 can be rewritten in prime factored form as 2 times 3 times 3, and then I have the k and the k times k times k. All right, minus. Now let's switch our attention to 24kt. So let's extract 24 and break it down into its prime factors. 2 times 12, and then break down 12 into 2 times 6, and then break down 6 into 2 times 3. All right, so we can express 24 as 2 times 2 times 2, 3 2s, that's 8 times 3, which gives you 24 times k times t. All right, plus. All right, let's now break down 8. How do we break down 8? We take out 2, 2 times 4, and then 2 times 2, breaking 4 further, and then 2 times 2 times 2 is 8. So we're going to have 2 times 2 times 2, and then we're going to introduce the t's, times t times t. Let me erase that a little bit. And then we have times t times t. Okay? Now let's see, is there anything common that can be pulled out of all three terms? Absolutely. 2 is common. We have 1, 2 here. We have there's 1, 2 in every term, all right? So we have a 2 here, we have a 2 here, we have a 2 here. So we can factor that out. Nothing else is common, all right? So when we factor out the 2, it's as though we divided everything by 2, right? So this 2 and this 2 and this 2 will factor out as 1 out here. Since nothing else is, since we have no other common factor, we're going to multiply everything back as it was originally. Okay, so 3 times 3, 9k squared, minus 2 times 2, 4 times 3, 12, 12kt plus 4t squared. Okay. Now this looks like a perfect square trinomial. We're going to do the test in a minute, but since we're assuming that this is a perfect square trinomial, we're going to use a factoring trick. Okay. So bring down the 2 in front, and then all you do is you're going to root the first term and the last term, and then bring down the middle sign. Okay. So the square root of 9k squared is 3k. All right. You divide this power by 2. And then you take the square root of the number, minus square root of 4 is 2, and then you divide that power by 2 is 2t. Okay, I use this formula because this is a square and this is a square. All right, so how do you know if this is a perfect square trinomial? If I double the product of these two terms, do I get 12? What is 3 times 2? 6 times 2, 12. Perfect, so it's a perfect square trinomial. So this is a factored form of our original expression. Okay? So there we have it. Okay. So thanks so much for taking the time to watch this video. Please, you can subscribe to get future updates and then share with your friends. More videos can be found on mytestchef.com. Thanks again.